So if you got an instrument that runs 100,000 volts per meter, and that's where the needle's pegged on a tri-field meter, at that point, we're out about 10 feet. When we take measurements, we talk about distances. I know one company, well, the one I was talking to early on in 2003, they claimed they were reaching out to 72 feet. But see, that's a misnomer. What was the actual volts per meter at 72 feet? Or was it just a little transistor radio that they had tuned to? Even this satellite going by Pluto is delivering a signal here to this world. But it's so infinitesimal, they need a radio telescope about this big to do anything with it and amplify it, see? So, 72 feet, I took measurements on those instruments a few years ago, 1 inch. And that's when the meter's pegged. Why is it I insist the meter's pegged? Well, when I was in the musical world, and I was young, when we turned on our amplifiers, where do you think we set them? There was only one place, 10. And then we put these LPB1 power amplifiers on, a little plug-in, and we had those dial up 10. My buddy couldn't get one to fit, so he notched out the amplifier casing to get it in there. Volume controls on instrument, 10. This, I can still hear, I'm surprised. Fortunately, back then we didn't go up more than 100 watts. By the time I got out, they were coming out with these 400 watt PV amplifiers. But here again, when I take measurements, if the needle isn't pegged, we don't count that. We're not going to, walk way out and that needle just barely tapping. Because it pegged, I have more confidence that we're actually getting something done. Where if that needle just doing this, it probably doesn't mean much of anything. See? And so when we look at output comparisons, I've done the math on some of these instruments. We're running up to 10,000 times the energy. Now we want to talk about application though. Yes, the needle's pegged when we put a bulb on, when we turn on that glass at 10 feet. But the square inversion law of electricity or electronics or EM fields will tell you that every foot you move away from that delivery system, the actual impact energy drops by 1/4. So I'm going to use a terminology you're more familiar with. Let's say we have 100 watts at 1 foot. That's the impact. We're used to thinking in watts, not volts per meter. So at another foot, you divide by 4, you're down to 25 watts. By 3 feet, you divide by 4, you're down to 6 watts and change. And by 4 feet, you see what's happening, how quickly energy dissipates. I still like my 3-foot circle, but at the same time, I still know at 10 feet, this new model is doing a lot more and probably is effective out there. But I've grown up around the 3-foot circle. See? Here again, if I went to a concert when I was young, I wanted to be in the first 3 rows so I could hear all the sound, all the noise. The last one I went to, Joe Satriani, I had earplugs in. But I guarantee you he was cranked all the way up to 10. But here again, we're going to war. When you go to war, you bring the biggest caliber guns you can bring with you. The largest weapons, because you're here to win. You're not here to play. Soldiers don't go to work. They go to war. They fight for their lives and they risk their lives to help others. And so that's why you're seeing such a huge difference. There's other reasons as well why our output is greater. Many companies, they're not putting electrodes in their tubes. If you were to look inside this tube, for example, if you could see inside here, you'll see these silver electrodes. You can see them on the double bubble that's burning in the entryway. But other companies wrap wire around the outside of the glass, and then they try to drive their voltages in there. And without a spark plug or an electrode, it severely cuts back the output. But it's a lot cheaper to make a tube without an electrode. You can do it for almost nothing. You need no special skills. Now that tube will burn out over time, where these do not burn out. But the output is so bad, it's like trying to eat a hot dog through your backside. It just chokes it when you try to drive that through glass, see? And the tube will light, but when you take a tri-field meter out, there's not much there. So that's just one problem. The other big one we're seeing, and this has been going on for years, is they're putting $15 sound cards inside of these instruments, and they're calling them frequency devices or Rife devices. A sound card's bandwidth is 20,000 hertz because human hearing doesn't go beyond that range. So why would you build a very expensive frequency delivery device that would go out to 800 million hertz like it does when the human hearing range stops at 20,000 max? You wouldn't. So they can build these little cards for 15 bucks, and they're putting those in instruments. Now comparing a sound card to a frequency generator at 800 million hertz of bandwidth is like comparing a slingshot to a shotgun. There's a big difference in how you deliver. And fractions of frequencies are very important as well. You can run 100 hertz, but sometimes you need to run 100.12. See, for example, to get the exact targeting with your harmonics. Now, some people will state that TrueRife, we don't have distance. They'll say that we're limited at a 10,000 hertz range. That is a misnomer because we drive what's called a square wave. This is technical, but to help you understand it, square waves generate harmonics. So when we drive 400 hertz, the next harmonic we're actually hitting is 800, and the next one is 1600, the next one is 3200. So you go all the way up to scale. Virtually our instruments go out to infinity when you drive a square wave. If you're driving a sine wave at 800 hertz or 400 hertz, that's all you're getting. But a square wave looks like this. And when I played music, one of the reasons we turned our amplifiers full was we got harmonics. You could hit the note and you'd hear, you'd hear that harmonic hitting. And it was exactly in scale. See? And that's what we're looking at here. So when we think about human hearing, I talked about the limit of things. If you are a musician, you may buy a tuner. Tuners are tuned to what's called A440. I didn't know until I got into Rife Instruments what that meant. The A note is 440 hertz. So if you were to type in 440 hertz on a TrueRife instrument and hold a guitar tuner in front of a bulb, the A note will light up or the needle will peg A perfectly. So it's a very inexpensive way to see how accurate your system really is. See, we use a Hertz meter. You can get them at Radio Shack. It'll show you the exact readout. But here again, that helps you understand that everything is in frequency, right down to our hearing and how things work.